Hello class, welcome to today's lesson. Today we're gonna do, this is still for March 16 class, so for today, and we're gonna 13.3 partial derivatives. So let's recall we did in Calculus 1A first, we are learning two dimension, okay? And partial derivative, we don't have partial derivative, we have full derivative, total derivative. So let's say if I want to find, I'm given a curve, the function represent is a curve with a y equal f of x. If I want to find the slope going through the point P, this is a tangent line at point P. I want to find the slope of this tangent line. I need to take the take one derivative, okay, first derivative, and I will get the slope out. But for three dimension, this for three dimension, how do we do it? Because the function, let's say this is a plane here, okay, a surface, and this surface represented by this function, and you can see this function two variable here, x and y. And if I have a point P on the plane, on the surface, if I want to find out the slope that going point P, we can draw many lines going through the point P here. Okay, we can draw a line like this way, like this way, like this way. We can draw many directions. We are not interested in any others right now. We're only interested on two dimensions, two directions. Okay, the first one we're interested on, if they respect to x, that means on the x direction, okay, parallel to x. So we use the rotation for f of x. That's a slope that going through point P on a direction for x, okay, parallel to x. So if you draw the line, okay, and this will be like this, okay, on the direction of x, okay. So I do my best. So this is a parallel, so that be f of x. And we use the notation, okay, f of x, or del z to del x, or del f to del x. And this is the first partial derivative with respect to x. It's also the slope, okay, the slope parallel to the x direction, to the x-axis. And then we are also interested on the y, okay, so the slope on the y direction, so parallel to it. So I do my best, so not exactly parallel. Okay, so this is fy. And fy, okay, is the first partial derivative with respect to y. And the slope should be, it's also the slope that parallel to the y direction, the y-axis. And we use this either rotation also. So any of these three rotation is okay. So now we're going to do what you mean by respect to x. So when respect to x, your y will treat as a constant or coefficient, like a real number. Let's see some example first. And I found I used the paper to clean my board. It's pretty good. It's better than use the eraser. Okay, so now we're gonna see some example, and then the first example we're gonna do is the problem number 18. Number 18. We are given z is equal to x e x over y. Okay, here's a function for two variables, x and y. So now we're gonna find f(x), okay. When we find f of x, so that means your y will be a constant or a coefficient. So now because x in the both places, so these are two functions here, a first function, a second function. So we have used the product rule. So we're gonna take the derivative x first, and then e x over y, and plus we keep the x, and then e x over y, and then we take the chain rule, okay. Now keep in mind, x is your variable. So this is a 1 here, so you keep this one. Now you keep these two take the derivative of this one. And x is a variable, so 1 over y, so it become a coefficient, so it's just 1 over y. So you can look at this as like this, okay, 1/2 x prime is just equal to 1/2. So you can look at it like this way. So now you can simplify if you want. You can take out this one, but you don't have to. But if you do, that's okay. If you don't, then that's okay too. Okay, those are for fx. Now we're gonna go for fy. Okay, for fy, this time you can look at the function here. You only have one place of y, so this will count as a number. Okay, so we don't do anything with it. We keep it. Now we take the derivative of this one. This time your y is a variable, the x is a constant, a coefficient. So you take, and that's equal to -1 over y squared. Okay, so that become your x is still there, so become x squared with this x. And this is a minus here, so y squared x over y. So that's how you do the derivative for fx and fy. And let's try the one. Okay. Unfortunately, I couldn't just answer you guys if you have any question, and I'm missing you guys in the class. So, but if you have any question, okay, you're going to take a picture of the problem and then you circle it and tell me which part you don't understand. Then I will explain it either on the discussion board or you can I will go through again on this part. Number 48, we have for fxy equal to sine xy, and at the point 2 and power 4. So what we're gonna do is that we're gonna get f of x first. They said find f of x, fy at this point. Okay, so we're gonna find f of x first before we substitute the point inside. So this will be sine xy, be cosine xy, and then xy prime. And because with respect to x, so your y will treat as a coefficient, a number, okay? So that just become y cosine xy. Now we're going to put the number inside, so fx 2 and power 4 will equal to your y is equal to power 4 cosine 2 times power 4, and that's a cosine power 2. Cosine power 2 is equal to 0. This whole thing equal to 0. Okay? And we're going to try the other one. So we're going to go fy equal to, so this time we still do cosine xy. Okay, due to sine is a cosine, and then chain rule the xy. Now this time my y is a variable, my x counts as a coefficient, so like 2y, kind of think of it like that, okay? So if you have 2y prime, it's just equal what? 2, that right? So you can, because x is like a 2 there, okay? So if you xy prime, it's just equal to x, okay? So this becomes x cosine xy. Now we're going to put the number inside. And then that become 2 cosine 2 times power 4. So that become 2 cosine power 2. Sorry about it below here. So that's just equal to 0. So that's equal to 0. Okay, so that's how you do if they give you a point. And let's try another one. Okay, we just need to keep practicing until we get it. And we're going to do a point number 61. And we are given f x, y, z equal to ln x squared plus y squared plus z squared. And when we see the ln, the best way is to simplify first, okay? So make this to be ln x squared plus y squared plus z squared, and then 1/2. And then we put the 1/2 in front of it. Okay, this go to the front. That way you don't have to have the square root. So once we simplify it, we're going to start with for f of x. Well, f of x, this time your x is a variable, the rest is a constant, okay? So 1/2, the coefficient, and then take the due to ln, that's a 1 over x squared plus y squared plus z squared. And then take the due to this one, that's the 2x. Due to this one's a 0, due to this one's a 0, so just 2x, and then reduce the 2. And that's your answer for f of z. And for f of y, if you look at the pattern of the problems, your fy will be the same answer as that, except this is a y. And then your fg will be the same answer also, except this is a z here. Okay, so this problem is a, do in a, little bit easier by simplify first. And hope you guys will get it, okay? And if you don't get it yet, we still have a couple more examples to go through. And I want you guys to also talk to each other on the discussion board to help each other out. The next problem is the number 72. Okay, we are given a function of a 2 variable is x squared minus xy plus y squared. Okay, they said find f of x and f of y. Okay, when they actually equal to each other and equal to 0, they said which point will cause that? Sy should equal to what? Then we give them this situation. So we're going to find f of x first. F of x, so this time your x as a variable and then y as a coefficient and a constant. So this is f of x be 2x. Subtract. Okay, now this time your y is a variable, y is a coefficient, your x is a variable. So this is a minus of y. And this is a constant, so y is out when you take the derivative. And then now we're going to get fy. Okay, this will equal 0. And now we get fy, so this is a constant now, so that's y is out. Now this one is a coefficient, this is a variable, so that becomes minus y. Okay, and then this one is a variable, so that's a 2y. I'm sorry, this part is wrong. Sorry about that. So this one is a coefficient, this is a variable, so minus x, and then plus 2y. And then now we're going to solve these equations, and you can see that you can solve the y out, y is equal to 2x. And then you put it inside here, okay, and solve for x. So you're negative x plus 4x equals 0. Add them together, 3x equals 0, then x equals 0. So when x equals 0, put it back here, then y is also equals 0. So that means at the origin, okay, at the origin, that's when they will have this situation. So that's how you do number 72. And the last thing we're going to do is called the mixed derivative, okay, mix. Okay, mixed derivative. What do they mean by mixed derivative? If you are given a function g equal to f(x,y), okay, and you can first find f of x, right? And then now after do that, you can do x again one more time, or you can do y. Or you can go fy and then find y again, and then you can go fy and then find x. Okay, this is called the mixed derivative. So let's see the examples. Here's a problem number 18. We are given a function g is equal to f of xy, and that's equal to x to the fourth subtract 3x squared y squared and plus y to the fourth. Here's the function, okay? Now we're gonna go f of x first. F of x, so x counted as a variable, so that'll be 4x cubed. And now this is a coefficient here, so don't do anything. So take the derivative this one, so minus 6x y squared. And that's a constant, so it gets y out. And then now we're gonna go f of sx, okay, x again. So that becomes 12x squared. So this is your variable, and that will be 6 minus 6y squared, okay? Now we're going to go to fy, your fxy, and that will be a constant now, okay? Because with respect to y now, okay, not x anymore, respect to y, so that become a constant here, so that's gone. This is the one you take the derivative, and that's a negative, for a derivative for variable, so that's a negative 12y. Let me see, this is 12, yes, 12y. And okay, 12 for x, 4x here minus 6x squared, and then f of x again, so that'd be, yes. And then now we're going to go, f of xy, I'm sorry, I make a mistake here. F of xy, so we use this one. And that's my mistake. So f of xy, so I take this one, okay? And I look at this one, so that was my mistake. So f of xy, so that we take the x here, this will be 0, the fxy is a negative 12xy. I forgot I used this one earlier. So it should be this one, okay? You go back to the original one. Now you go fy. Fy start from here, so that be 0. That be negative. So this is a coefficient here, so that's a negative 6x squared y plus 4y third. Use this one, okay? I make a mistake earlier. I use this one. So fxy, use this one to get fxy. Now you go get fyx. Okay, so take this one to get this one. So that'd be negative 12xy. And that's what? 0. That right? Now you go fyy, use this one. Okay, fyy. So this one for here and this one for this one. This one for this one. Okay. fyy, so that would be here. So this is a coefficient now. The y just a negative 6x squared. Go first derivative for y just 1. And then plus 12y squared. And I want to look at this. Okay, do you guys notice that there's something interesting going on here? So if you look at fxy and then fy for x, and you find out these two are exactly the same. Okay, Nico. And that happens all the time. Okay, so fyx, fxy are actually the same thing. And that's to the end of today's lesson. Okay, see you tomorrow.